Before we start this video, a large thank you to Amazine, Edward, Josh, Jims, Saiko, Ozaki, Sao, Clavix, TV Hambika, and Aoman for their support on Patreon. I hope you guys enjoy the video. And an immense thank you to Halo Burner for their continued support of the channel this month on Patreon. I greatly appreciate it, my friend, and I hope you enjoy the video. Gentlemen, it is a beautiful day, and we're going to work on our AI. So I'm going to hop into the world scene, and I'm just going to make an empty game object over here. And I'm going to call this AI Patrol Pass. And I'm going to reset it at world position 0. I'm going to haul this guy out in this room over here. So I'm going to give it a child object called Patrol Path 01. And at this point, I'm going to make a random capsule in the world, like so, and give it a material that stands out so I can see what I'm doing. This is going to act as our patrol point. We're going to make a bunch of these just so we can see in the actual scene view where we're placing these, because just using those little arrows down there for empty game objects can get a bit confusing. So I'm going to give it a brighter material. I'm just going to copy one of these ones that I have now and give it some emission so I can really clearly see where this is and what's happening in the scene. And at whichever point I'm satisfied, I'm going to rename the capsule to Patrol Point bracket 0 bracket. And I'm going to parent it under Patrol Path 01. I'm calling it Patrol Point bracket 0 bracket because we can duplicate something in Unity and it already has the same name. It gives it that name with a bracket followed by a number like this. You can see I have Patrol Point 0, 1, and 2 in here now. If I duplicate 2, I'd get Patrol Point 3, and so on and so forth. So take your original point here. This is my starting point in the patrol, and then duplicate this, and this will be your next point. And these numbers serve as the order in which the AI is going to navigate these paths. So starting at 0, then going to 1. We duplicate this it becomes 2. And keep in mind, since it's going from point to point, it's going to take the shortest possible path to the point that you make next in the list. So keep that in mind as you're placing them. If you want it to, behave a certain way or walk a very specific path, you might need to put more points in between certain areas. So when you're done, it should look something like this. I just made a random nonsensical path just to make sure this works. Obviously, I'm not putting too much thought into how this is going to be laid out. Now go to your parent object, Patrol Path 01. Because you can make multiple paths. Obviously, this is Patrol Path 01. Add a script called AI Patrol Path. Delete the start and update functionality as is per tradition. Dropping your namespace. Mine is SG. And then let's make a couple variables here. So we're going to need first a public int for the Patrol Path's ID because it's very likely that you're going to have more than one patrol path in your game. So you need to label them as such and give them an ID so your AI knows which one to grab. And then let's make a list, not audio listener, and we need to say up here, using system.collections.generic, I believe, for list. Yes. So make a public list for vector3. So vector3 positions. Call this patrol points. Now you could serialize this and drag them yourself, but we're going to equal it as a new list, and we're going to get on awake instead. So this is automated and saves us some time if we want to make a bunch of these. We get on awake by basically going and checking using a for loop all of the child objects under this main game object by saying for transform.childCount, and then we're going to say patrol points.add, and then we're going to say transform.getChild, and then we're going to say brackets I. So this is basically just going to go through every I.position, my bad. This is basically going to go through every child object here, get its position, and add it to your list of total patrol points in the order that it finds the children game objects, which means it's going to go from point 0 to point 20 something, provided you have them in that order. Next, we're going to go over to the World AI Manager. Let's make a header called Patrol Paths. We'll make it serializable so we can see it in the inspector, verify that it does in fact exist. Let's make a list of AI Patrol Paths, and we can call this AI Patrol Paths. So again, you don't need to make this serializable if you don't want to. I'm just doing this so I can verify that basically that if I check in the game here, it will have added my list to this list of paths. And I'm going to make this a new list, initialize it as a new list rather. And then down here, I'm going to make a comment for patrol paths. I'm going to make a public void add patrol path to list. Going to make it require you pass a patrol path, call it patrol path. We're just going to simply check if the list already has this. If it does, return. Otherwise, we're going to add this list to our list of patrol paths. Now, before we leave here, we're going to make one more function. It's going to be a get function, which will get us a path. So we're going to make a public AI patrol path. We're going to call this get AI patrol path by ID. Very clear what that does. We pass it an ID. It gives us back a patrol path. So we're going to say get AI patrol path by ID in patrol path. Then we're going to say for, do a for loop here. We're going to check every single path that we have in this list. And if we find one that matches the patrol path ID that we passed, we're going to pass that back. Now, we always have to pass something here, so we'll have to pass null if we don't get anything, which we'll do in a moment. So if AI patrol path patrol path ID is equal to patrol path ID, then of course you have your patrol path. So you can't say return patrol path though, because what happens if it doesn't exist? Like I said, we have to return something. So let's make a local variable for AI patrol path. We'll say patrol path is equal to null by default, and then if you actually find a path matching that ID, we will instead say that this patrol path is equal to AI patrol paths I, and then regardless of whether or not it's null, we will return the patrol path variable we made above the for loop. All right, cool. We have a list of paths. We have a way to get paths by their ID. On awake, let's add this AI patrol path to the total list by saying world AI manager.instance add patrol path to the list. Save. All right, coming to the game here. I still got my dead spot from where I died last time. Let's go over to the patrol path. You can see, boom, yes, it has a path, and there is all the points on that path. Pretty cool. So it is giving you the world points, the positions, by the way. So over here, AI patrol path, there it is, and there is all of the points on our path. All right, next, let's go to the idle state. So what happens if you want to do multiple things on an idle state? Because an idle state, it isn't just standing around all the time. What if you want to have some idle people patrol? What if you want to have some sleep, or what if you have some traps? So we can make a way to do this right now. Let's go over to our enums, and let's, I'm just going to make sure I don't already have something for AI here, so I'm just going to do a quick search. Oh, so we have AI states, Control F, AI. I don't think we do. I don't think we've made any AI enums yet. No, we don't. Okay, cool. I'll just put it down here at the bottom. So AI states public enum. I'm going to call this idle state mode. I say mode because, like I said, different idle states can do different things. I guess idle just means idling around, but in our sense, idle is the AI doing nothing or doing something before it engages with the player in some way. So they're not trying to kill you. Right now, we can make two enums. We'll say idle and patrol. Idle is your standard do nothing. Patrol is going to be patrolling a path. Now, I have sleep, trap, wander, all that stuff in Nephilim. If you guys want me to cover all of those too, just comment below. If you want something covered first, though, let me know also. So right now, we're just going to do patrol. If you guys want to see more, cool. If not, I can move on to something else. And like I said before too, if whatever else you want to see in AI, please mention it now, because we're going to do a few AI episodes. I know I think some people want to see like combat circling and that stuff, like having the AI kind of walk around you, use horizontal movement, not just vertical movement. But whatever you want to see first, let it be known now, because I will be doing these videos in the next coming weeks. So two variables here, idle state mode, and that's the idle state mode variable, and then the integer variable for patrol path ID. We're going to have a few variables here. I'll explain what they do. So which path are we using is the ID. Bool has found closest point near character spawn. This just means if you start your character in the world somewhere and they're like in the middle of the path, then let's start in the middle of the path instead of starting at the beginning of the path, because that doesn't make sense. That way multiple characters can share one path. Patrol complete, self-explanatory. Are we done the patrol? Have we finished it yet? Repeat patrol, I feel, is also very self-explanatory. Are we going to repeat this patrol once we finish what we're currently doing, or this patrol? So basically, you keep doing it indefinitely. Then we're going to say serializable field. I'm ripping this code straight from Nephilim, by the way. So if you guys find any issues with it, please let me know. Patrol destination index. I say that because I'm not going to test it as extensively in this video, because I have seen it working in Nephilim. But just in case, if you guys figure anything out that doesn't work as it should, just please let me know. I will immediately address it. Patrol destination index is which point we are at in the patrol. So if there's 15 points and we're at point 12, our index is point 12. I hope that's very clear. Bool has patrol destination. This just means, do we already have a destination? Obviously, if we're walking towards another destination, then we do. If we don't, then we should immediately try to get a new destination. So we should always have a destination unless we're done. So do we have a point we are currently moving towards? That's that put simply. Right below that, another serializable field. You don't need to serialize these, by the way. I'm just doing it so I can see things in the inspector. Vector 3, this is going to be the current position we're actually actively moving towards. Again, you don't need to serialize this. I just like seeing it in case something is not working as it should, so I can kind of check out what's going on. So this specific destination coordinates we're heading towards, this should be in world coordinates. And then we're going to go right below that, serializable field again, and we're going to make a float for the distance from our current position. So I'm keeping track of this because if you, say, accidentally put one of these positions half underground or half above the ground, and your character can't actually get to the perfect position, then they'll basically wander in circles aimlessly forever, and you don't want that. So it's good to get either give it a buffer or check if the destination is reachable on the nav mesh. Either of those things will do. Then we're going to do time between patrols. Then we're going to say the minimum time before you start a new patrol. So basically, if you're going to repeat the patrols, you can make them break briefly. I'm trying to cover as much of this as I can and give it as much detail as I can, so you can kind of have a very good framework to change or mess about with whatever you want. And the timer. So this is the timer that we're going to count after each patrol, and it's going to increment up until it gets to the default time you want to wait between patrols, and then it will go again. So we ever have an active timer that we're waiting to rest, and I'll say the default time between patrols is 15, and the rest timer obviously starts at 0. All right, with that being said, we can actually start writing out the logic now. This is going to be relatively straightforward, because again, I'm just going to rip this one for one, so if you guys have any issues with it, let me know. I haven't seen any in Nephilim. It's been working as intended from what I see, but of course I could have missed something. So, protected virtual AI state idle. I'm saying virtual in case you want to override this on other characters' idle states. So we're going to make one for idle and one for patrol. If you hadn't caught on, we're going to make one for every possible idle state mode. So if you have wander, sleep, you can make those as well. So again, AI state idle, which is the true idle, you do nothing. And then patrol, we're going to walk around and do our patrol path until we find somebody. Or just indefinitely if we never find anybody. So under the regular state tick here, we can move some stuff around. Let's move find target right up here at the very top. By the way, optimization tip for you. You don't need to run find target via line of sight every frame. If you want, you can just fire it once every second. So it's not constantly running if you want to, min-max your optimization. But for now, this is fine, so we'll keep it as such. I'm going to run a switch statement here, and we're going to switch our idle state mode. You can get rid of the breakpoints because we're going to do returns. So we're going to say return if the idle state mode is idle. We're going to return our idle function here. If the idle state mode is patrol, we're going to say return patrol. And again, once you use the keyword here, return, you're going to get some little green text, green lines under these breakpoints, so you can just erase them because they're not required any longer. Now, under the idle state, we're just going to simply basically see if we have a target, and if we do, then we're going to return to the pursue title state. Otherwise, we're going to keep returning as if nothing happened. And patrol is obviously going to be a bit different. So let's come out here, and we're going to say if the AI character .ai character locomotion manager is not grounded, we want to return this as in do nothing, because you should never attempt to move if you're floating in the air. And then we're going to say if AI character is performing action, we want to return and also disable our nav mesh agent and stop ourselves from moving, because you don't want to try to move around while you're in an action. So nav mesh agent enable is equal to false. And I'm going to set my, I don't think we've actually set our animator values in this series yet, have we? We haven't done that with AI. No, we just use is moving. Okay, so I'm going to set the is moving network variable to false. And that in turn should change our animator values to 0, if I remember correctly. If not, I guess we'll figure it out. So we're going to come right below that and say if the AI character.navmesh agent is not enabled after this, we want to, of course, enable it. AI character.navmesh agent. By the way, if you're ever not using the navmesh agent, like when you're ever doing an action, you should always disable it. If you're doing a normal action where the character is not meant to be moving, always disable that. And always re-enable it when you just need to use it. So if the AI character combat manager current target does not equal null, then we're going to switch to our pursue target state, just like above. If we have a target, notice though we are checking for being grounded first and for doing an action. And then if we pass all that, then we can actually switch states and move on to our pursue target state. All right, cool. If the patrol is complete, we got to handle that first. And we're going to repeat the patrol. We're going to reset some things in here just to make it kind of go over the patrol again. I'll make a comment here. So if our patrol is complete, man, there's a joke about programmer comments and them just saying exactly what you're writing. And this is definitely one of those cases. And we will repeat it, check for time, reset time, I'll say. So let's go ahead and do that. We're going to say if the reset timer, if the time between patrols is greater than the reset timer, then we're going to say reset timer plus equals time.delta time, and we're going to disable our nav mesh agent and our is moving status again by setting them to false. Just going to copy and paste that. And then we'll say rest timer plus equals time.delta time. Otherwise, then we know we're good to go. Make a comment here too. If the time has not exceeded it's what I'm going to call a set limit. Yeah, that's a good way to describe it, I guess. Stop and wait. All right, otherwise, what we can do underneath here is say patrol destination index equals -1. That just resets it because we're going to add 1 to it in the future and bring it back to 0. So we'll start at 0.1 basically. Then we're going to say has patrol destination is equal to false. So we get a new destination. Then we're going to say our current destination is our character's transformed opposition. So the last point they were at. And then we'll say patrol complete equals false. So if it was complete before, again, it just resets it. And then we're going to say rest timer is equal to 0 to reset that as well. All right. Otherwise, we're going to say else if actually. So we're going to say else if our patrol is complete and we do not repeat the patrol, then we're going to basically just disable our nav mesh agent and our is moving flag and kind of hang out. All right, so we've done all that now. Patrol is done. How do we actually get through the patrol? Well, first we got to check to see if we have a patrol destination. Whoops, wrong call. Not if we find the closest point, not yet. First, we have to check for has patrol destination. So if we have a destination, what are we going to do? Well, we want to move towards that destination, right? So we can say distance from current destination is equal to vector3 dot distance. We pass our current destination and our AI character transformed opposition. Now, like I said, you might want to make the distance buffer a little bit so we can say if distance from current destination, I'm going to say 2 meters. That's very generous. You don't need to be 2. I'm sure 1 is fine. So if our destination is greater than 2, implying that we're not within that limit of 2, I'm going to say AI character.navmeshagent.enabled equals true. And then I'm going to rotate my character towards nav mesh agent. I'm actually almost certain we made a function for this real quick. Future step here. We did indeed make a function. I'm just going to write this out and see AI character transform rotation. And we're going to pass the, actually, just let me check this. I'm going to go to the AI character.locomotion manager and see rotate towards agent. Yeah, there it is. Okay, we can just call that instead. Let's erase this and call AI character.AI locomotion manager dot rotate towards agent. And then we're going to pass AI character. So let's right below that now pass an else statement. All right, so if we get it within 2 meters, then it means we've gotten to the point. So we can say current patrol destination is equal to our current character's transformed opposition, and we can say has patrol destination equals false, which will make us get a new one. So you can make this number smaller, or you can check to see if the position you're trying to walk towards is valid and you can get there. So basically, if you don't make this number, if you don't do either of those things, your character is getting to a point where they keep walking towards the destination but can never actually get perfectly on it. Like say if you put it through the floor a little bit or in the sky a little bit, and they'll end up just walking in circles. So you either want to have that buffer or check to see if the position you can get is actually accessible. Both approaches are valid. So again, otherwise, we need to get a new destination. So what we do when we get a new destination, we increment our index by equaling plus equals 1. I'm not sure why all this is green underlined because I know we are most certainly using it. Might just be a bug in Visual Studios. Let's make a serializable field for our AI patrol path. So if you have a patrol destination, walk towards it. Otherwise, we need to get one. So patrol destination index plus equals 1. We check to make sure our index is not out of bounds by saying if patrol destination index is greater than our AI patrol path dot patrol counts minus 1, then we're going to say patrol is equal to complete because we've exceeded the last point, and then return this. Otherwise, we're going to check first, have we actually found the closest point that we are near? And if we didn't, it means we haven't gotten to our first point yet. So we're going to say has closest point near character spawn is equal to true. And then we're going to mathematically here determine which point we are closest to. We do this by making a variable for closest distance, equalize that math f.infinity, meaning it's just infinity for now. And then we go through each of our AI patrol path patrol points, and we get the distance from them to our character, and we store the shortest one. We do that by saying float distance from this point is equal to vector3.distance. We pass the AI character's transfer position and the path's specific position by saying AI patrol path dot patrol points I for this specific one in the for loop. And then we say if the distance from this point is indeed shorter, smaller than our closest distance, which at first it has to be because the first one's infinity, then we're going to say closest distance is equal to distance from this point. But that's not all. We then want to basically iterate and say this will be the point that we're at on the index, and this is our current point that we're going to basically start at. We do that by saying patrol destination index is equal to whatever I was, because that's the position in the list of patrol points. And then we're going to say current patrol destination is equal to AI patrol path dot patrol points I, just like that. So that will just set that as our first place to move towards. Otherwise, if we've already done this once, we don't need to do it again. We can just get a new destination by saying current patrol destination is equal to AI patrol paths, and we pass our index. Because again, if the index is exceeded, we know we're going to stop. Otherwise, we still have more points to go through. Then we're going to say has patrol destination is equal to true. And lastly, we build the nav mesh path by saying nav mesh path. And I'm not getting anything here, so I have to come up here and say using unityengine.ai. That is still underlined in green. I'm not sure why, because I know for a fact we're using this. I mean, we'll see in the game if it doesn't work. Nav mesh path is equal to new nav mesh path. And then we're going to say AI character dot nav mesh agent dot calculate path, and then we're going to pass our current patrol destination and pass the path variable we just made. And then we're going to say AI character dot nav mesh agent dot, and then set path. Then we can return this. We can save that. All right, jump back into Unity, go over to your AI character, and we're going to want to make a header under AI character spawner, sorry, not AI character. And we're going to make one called patrol. Next, we're going to make a serializable field for a bool, and we're going to say has patrol, because not everyone has a patrol path, obviously. So defaultly, I'll enable this at false. And I'll call this has patrol path, because that's more clear, in my opinion. Serializable field, int patrol path ID. So this just is only going to be useful if you actually have a path. And then we're going to come down here to where we attempt to spawn character. If the character does not equal null, actually I'm not even going to use some of these curly braces. I'm just going to basically do a quick return if it is null, because we're going to put more logic below here and it just looks cleaner. That's all. So if AI character is null, return. Otherwise, do all the cool stuff below that you would normally do if you had an AI character. So we're going to add the AI character to the world AI manager list, of course. And we're going to say if we have a patrol path, the AI character dot idle, as in the idle state, dot patrol. Now we actually have to make this public. Let's use the patrol path ID here. We can set that to the ID of this AI character spawner. So we can say patrol path ID is equal to this. So we can save this. And now that I'm thinking about it, I'm being a little bit redundant here because I could just get the path myself from the World AI Manager and pass it, which we're probably going to do. Before I do that though, let's go over here and set this patrol path ID to 1 just so we know it's going to work, because defaultly all of our variables are at 0 now. But I wanted to search for the list of paths and get one with 1 so I know it's actually grabbing the path correctly and not just getting the default 0 path. So let's go over to the, where am I going? The dummy here on the undead idle state. Make sure this is on patrol for the idle state mode and not idle. Make sure your patrol path ID is 0 because I want to make sure it's grabbing appropriately and not just getting it because it's already 0 by default. And we're going to make the patrol variable public. Not the patrol. We can just get rid of the patrol path variable over here. I see this now. This is a bit of redundancy. So let's just get the path and make the path public. It's just better to do it that way. It makes way more sense. AI character.idle.ai patrol path is equal to world AI manager.instance.get patrol path by ID. We pass a patrol path ID. Future Seb here. You might want to make a check. If a path is null here, set the AI state mode to idle, not to patrol, just as a catch. Okay, why is he walking towards the wall? Ah, right. So over here, you see how our nav mesh agent is outside the wall somehow, even though we spawned our character over here? Well, we actually spawned our character in the world, then set its position. So for that small increment of time, that nav mesh agent is actually at 0, 0 in the world, I believe. Go to your AI character manager. This isn't going to fix the problem, but this is going to be a failsafe for some other small problems you might encounter in the future. Basically, you want to make sure your nav mesh's, your agent's position is always zeroed out under your character, because we're using a hybrid approach that I won't go into detail on because I've discussed this in previous videos. Basically, we're using our nav mesh agent to get a path, but we're moving with our character's animations. So if your nav mesh agent is null, simply do a return before you even process a state machine. You should even go any further. If your nav mesh agent is not enabled, return. This is after you check for the state machine, obviously. Make sure that's after that. And then we're going to set it, or rather make a variable here called position difference, which we get the difference in position for our nav mesh agent's position and our position. We're going to say if the position difference dot magnitude is greater than, we'll say 0.2f, we're just going to reset the nav mesh agent's position, local position, to vector 3.0. That will just make sure that the nav mesh agent is perpetually under the character where it should be, because we're using the nav mesh agent for its rotational values, but we're not actually moving the character with it. So if I go over here though, you still see there's a problem. Why is it doing this? We're resetting it at 0, right? Well, here's the weird part with Unity. I don't know why this happens, but I know how to fix it. I'm just unsure as what happens. You can see here if I pause the game, the nav mesh agent is most certainly not at 0, 0, 0, although its transform reflects that. It says, hey, I'm at 0, 0, 0. Even weirder, if I move the character through the wall, it does go to 0, 0, 0. If I move it back, it doesn't. It's because it doesn't want to come off the nav mesh, but it's weird that even with the game paused, unless I disable the agent, as you just seen, that it won't actually stay underneath the character. This is why I said, so go to your prefab and make sure your nav mesh agent starts off disabled. Always disable your nav mesh when you're not using it for something. And now if I go back to the game, you can see it's working perfectly. You have no idea how long it took me to figure out the first time I saw it go through a wall and was wondering, why is this happening? All that time ago. Anyway, so he's going to the point here. He's fine. I think he's a bit off the ground because I don't have my my ground check sphere set to a small enough value. I think it's like the default value, which is 1 meter, which is why he's hovering a little bit. Anyway, he is walking towards the points, as you can see, and he's getting within 2 meters of them, and he's stopping. Now, if you don't like this lack of precision, again, I think setting it to 1 meter is fine, but alternatively, you can check to see if the point is actually reachable on the nav mesh, or even more creatively, you can take these patrol points and actually have them ray cast down to the nav mesh and make their new position wherever they hit on the nav mesh, then use the exact position of each of these points, which is a bit easier to do because then you could have them levitate off the ground and have them lock into the ground when you start. These are fun things for you to try on your own for sure, because I can see now some people probably won't like this big gap here in the space. But I encourage you to try that out. It will be a great learning experience, really get you thinking. And he's definitely levitating here now. I'm going to fix that real fast. 1 second. Okay, he's better. It was the ground check. But yeah, he is walking around here now, guys. You have a working patrol system. And now I did check to see if he would make it to the end. He absolutely did. He's just going very slow, so I won't put you through that. I did not check the repeat patrol in this project, but I did check it in Nephilim several hundred times, and it was working over there, and I did rip the code straight from there. But if you guys have any issues with this, please let me know, and I will address it. If you want me to add anything onto it, like if you can think of some cool features that you'd specifically like to see in a patrol, please let me know. I will also do that. And if you have any AI features you specifically want to see next before I start anything else, please let me know and I will do that. Because if not, I'm going to move on to sleep and ambush states, and I'm going to move on to cool little combat interactions, and I'm going to move on to AI making motions towards sound that it detects. So basically it'll enter like a search or investigate state, and a bunch of that cool stuff. In the future also, going to do weapon upgrades, and then finally, I'm going to show you how to put the project on the Steam. I'm going to show you how you can get into the game and invite your friends via Steam. And after that's done, we're going to go over basically client-side predictions. So if you have a bad connection to me, let's say you're like 150 ping, and you hit a character, instead of waiting for the server to get that hit and then send it back to you and play the animation, we're going to make it so the enemy will automatically play the animation instantly on your end, and then it will try to sync up the progress between the two of us if you're a bit behind. That's a bit more of a dense topic. It's not hard. It just takes some planning. So we'll cover that, and we'll go over all the features we implemented, and we'll give them their kind of prediction towards the end. So yeah, one last time, if you want to see anything else, now is the time to ask me. Beyond that, that's all I got to say, because at this point I'm rambling. I hope you guys have a very lovely weekend. Thank you, as always, to my patrons, all of you guys who like and comment the videos. It really means a lot, and I appreciate you being here, and I will see you guys next week.